Okay, finishing up learning target 2. We are on part 3, which takes us to decimals. Okay, decimals are not as complicated as the fractions. So again, we have our adding and subtracting rules, which are different from our multiplying and dividing rules. Nice little review we're going over here. These are going to be in all the little problems you see throughout the year, so we want to make sure we're really good with these, okay? Just like when you add fractions, you have to make sure you have common denominators. There's also something you have to make sure is true when you add decimals. It doesn't have anything to do with common denominators. It has something to do with your decimals being lined up. Okay? So if I ask you to add $4.32 to 80 cents, then you know that you're not going to just add 8 to this. You have to line them up. So I have, when I teach this to some of my 7th grade classes, I will actually give them a piece of paper with the decimals already on it, and they just have to fill it in. So that's 80 cents. So then the other rule to remember is when you add decimals, remember your decimal comes straight down. Okay, and then you add from right to left. So this is 2, this is 11, carry that over, and you got 5.12, okay? The tricky part would be is, what if I had it negative 4.32 plus 0.8? Okay, this could be a little tricky because essentially the work that you'll be showing, well, in this case it's not, I'll show you a different one. You are looking at the signs are different, and according to the addition rules, when the signs are different, you subtract. And you always subtract the smaller one away from the larger, meaning the absolute value of it. I know that this one's smaller than that, but the absolute value of this is bigger than this one. So I'm going to set it up the exact same way. So 4.32 plus 0.8, and we're going to take this and this. Actually, we're going to do this. And it's going to be the same way, except I'm not adding. This time I'm subtracting them. So it's almost like I kind of can move that aside for a minute and do the sign after the fact. 2 minus 0 is 2. This becomes 13. And this becomes 3, right? Decimal comes straight down. This is 5 and this is 3. But be careful, because if you take care of that sign after the fact, you may move on and forget, oh, is this positive or negative? So I have more negatives than positives. Don't forget that. So that is kind of like a, you don't set it up necessarily. This is more like a scratch work type of deal for that, okay? So just remember. Let's do, let's take one like this to kind of get you to understand what I mean by that. So if I have 7.34 plus a negative 10.6, okay? This is a great example. Hey, I'm almost done. So 7.34 minus 10.6. Come on in. What's up? I will, yes. Easiest? Okay, yeah, I won't go that way. Thank you. I'm talking to myself. I'm recording. Thank you, Priscilla. So I have 7.34 minus 10.6. So in order to set this up, unless you could do it in your head, you're really looking at this as, okay, if this is an addition and this is a positive and this is a negative, I really want to take remember I said take the smaller number away from the larger number. So this is really the problem that I'm going to do, and then I'm going to figure the sign out after the fact. So even though in most normal subtraction problems, this first one has to go on top, doesn't it? Okay, so that's kind of why I wanted to specify this. So I really want to subtract this from that. Let's make this a 10. Let's make this a 5. Bring your decimal straight down, okay? And then that's going to give me 3.26 or 3 2600ths. But this 10 is larger, so we don't forget to make that a negative, okay? So you really kind of, I know it goes against everything you've been taught to put this number on top, but when you're dealing with negatives, all these rules change, okay? And now let's talk about multiplying and dividing. kind of like with fractions, when you don't have to have a common denominator for multiplying and dividing, you don't have to line the decimal up for multiplying and dividing decimals. So let's start it with something real simple. If I have this is the best thing I like to show people. If I have 4 times 3, right? That's 12, okay? If I have 0.4 times 3, that's 12, because 4 times 3 is 12, but you move that decimal over once, there you go. If I have 0.4 times 0.3, I ignore the decimals. 3 times 4 is 12, and then 1, 2. So you remember, you move your decimal, the total sum of all the decimals showing in your problem. Okay? If these numbers aren't able to be done in your head, like 4.3 times 0.9, okay? I mean, you could do that in your head. So then go ahead and just do it and ignore the decimals. So 9 times 3 is 27. 9 times 4 is 36, 37, 38. Okay, go ahead and write 387. But don't forget to go and count the decimals in your problem. And 1, 2. So you got +1 here, which means +2 there. Make one of them negative, and now it's negative. Make them both negative, and now it's positive. Okay? Same rules with that, for the fraction like that. And then the last one to kind of review real quick here is dividing real numbers, so dividing decimals. If you have, let's look at this one, 2.5 divided by 1/4. Okay, that doesn't look fun, but did you hear what I said when I said it? 2.5 divided by 1/4. If that looks confusing to you, then write it how you're used to it. Doesn't this translate to that? Then isn't 2.5 the same as 5/2? And don't divide by 1/4. Multiply by 4/1. It's multiplicative inverse, right? And then you cancel. Let's make both of these negative. Negative divided by a negative is going to be a positive. This is 2, so that answer works out to be 10, okay? And the only other thing to look at is this. If you have 6.8 divided by 4.2. The only last thing, and I'm hoping you remember this from 6th grade, this means that it's 6 8/10 divided by 4 2/10. Oh my goodness, which one goes here? Which one's being divided? You're taking the 6 8/10 and dividing it by 4 2/10. And the rule we have to remember with dividing with decimals is that you can't divide by a decimal. Okay? So you can't divide by a decimal, so we're going to take and multiply it by 10. If we multiply 4 2/10 by 10, won't that just bump that decimal all the way to the end and make it 42? But I can't bump this to the end without bumping this to the end. So 42 and 68, that's my new problem. Okay, 68. And then depending on what kind of answer I want you to give it as, obviously 42 can fit in once. Do a little bit of long division. When you do your subtracting, you get 26. Okay, you have a decision to make. You can put your answer as a decimal, which I think is a little harder, or as a mixed number. So let's look at mixed number. Mixed number means there's my remainder. I have a remainder of 26. 26 goes up here. 42 comes here. What did we say about always reducing? So this answer is going to be 1 and 13/21. If that's negative, then now it's negative, right? If you went the decimal route, which I probably wouldn't, then you would just do this, right? Bring that decimal straight up. 1. That's going to give you 26. Then you would bring down that 0, and then you keep going and going, depending on if it's terminating or repeating. So that is your refresher, your review for Unit 1, Learning Target 1-2, performing operations with real numbers, because you're going to have to do these a lot this year. So it's a good way to kind of start the year off.